The climate of our globe at present day is characterized by a succession of seasons: spring, summer, autumn, and winter, caused by the inclination of the Earth's axis to the plane of the ecliptic. When the North Pole of the Earth is turned away from the Sun in its annual course around that luminary, we have winter in the northern and summer in the southern hemisphere, and vice versa when the North Pole is turned toward the Sun. The cause of the rotation of seasons in the different hemispheres is thus very simple, and from the permanence of this cause, one may be led to think that the distant geological ages, the climate of our planet must have been characterized by similar rotations of hot and cold seasons. But such a supposition is directly contradicted by geological evidence. The inclination of our Earth's axis to the plane of the ecliptic, or what is technically called the obliquity of the ecliptic, is not the sole cause of climatic variations at the surface of the globe. High altitude, the existence of oceanic and aerial currents, carrying and diffusing of the heat of the equatorial region to the other parts of the globe, the distance of the planet from the Sun in the rotation, and high altitude, have found to produce different climates in countries having the same latitude. The Gulf Stream is a notable instance of such oceanic currents, and had it not been for this stream, the climate of the northwest of Europe would have been quite different from what it is at present. Again, if the masses of land and water were differently distributed from what they are at present, there's every reason to suppose that different climatic conditions will prevail on the surface of the globe from those which we now experience. And such a distribution would materially alter the course of the oceanic and aerial currents going from the equator to the poles. Therefore, in early geological ages, when the Alps were low and the Himalayas not yet upheaved, when Asia and Africa were represented only by a group of islands, we need not be surprised if, from geological evidence of fossil fauna and flora, we find that equable and uniform climate prevailed over the whole surface of the globe as a result of these geographical conditions. In the Mesozoic and Cainozoic times, the state of things appears to have gradually changed. But though the climate of the secondary and tertiary was not probably as remarkably uniform as in the primary, yet there's clear geological evidence to show that until the close of the Pliocene period in the tertiary era, the climate was not yet differentiated into zones, and there was then no hot or cold extremes, as we find at present. The close of the Pliocene and the whole of the Pleistocene period was marked by violent changes of climate, bringing on what is called the glacial and interglacial epochs. But it was now conclusively established that before the advent of this period, a luxuriant forest vegetation, which can only grow and exist at present in tropical or temperate climates, did flourish in the high altitudes of Spitzbergen, where the sun goes below the horizon from November till March, showing that thus a warm climate prevailed in the Arctic region in those days. It was in the Quaternary, or the Pleistocene period, that the mild climate of these regions underwent sudden alterations, producing what is called the glacial period. The limits of this glacial period may not so exactly coincide with those of the Pleistocene as to enable us to say they were mathematically coextensive, but still, in a rough sense, we may take that these two periods coincided with each other. It's impossible within the limits of a short chapter to give even a summary of the evidence proving the existence of one or more glacial epochs of the Pleistocene period. We may, however, briefly indicate its nature and see what the geologists and physicists have to say in regards to the changes which were brought about in such extensive changes of the climate in the Quaternary era. The existence of the glacial period is no longer a matter of doubt, though scientific men are not totally agreed on the causes which produced it. Ice sheets have not totally disappeared from the surface of the Earth, and we can still watch the action of ice as glaciers in the valleys of the Alps or in the lands near the pole, like Greenland, which is covered with a sheet of ice so thick as to make it unfit for the growth of plants or habitation of animals. Studying the effects of the glacial action in these places, geologists have discovered abundant traces of similar action of ice in former times over the whole of northern Europe and America. Rounded and scratched stones, glacial till or boulder clay, and in the rounded appearance of rocks and mountains, clearly point out that at one period in history of our globe, the northern parts of Europe and America must have been covered for a long time in a sheet of ice several hundreds of feet in thickness. The ice which thus invaded the northern portions of America and Europe did not all radiate from the pole. Evidence of the direction of the striae, or scratches, engraved on the rocks by ice undoubtedly proved the ice caps spread out from all elevated places or mountains in different directions. These ice sheets of enormous thickness covered the whole of Scandinavia, filled up the North Sea, invaded Britain down to the Thames Valley, greater portions of Germany and Russia as far south as Moscow, and almost as far east as the Urals. It was calculated that at least 1 million square miles in Europe, and more in North America, were covered by the debris of rocks ground down by these glaciers and ice caps. And it is from this debris that geologists infer the existence of Ice Age in early times. The examination of this debris shows that there were at least 2 series of boulder clay, indicating 2 periods of glaciation. The debris of the second period has disturbed the first layer in many places, but enough remains to show there were 2 distinct beds of boulder clay and drifts belonging to 2 different periods. Professor Geikie mentions 4 such glacial periods with corresponding interglacial periods as having occurred in succession in Europe during the Pleistocene period. But though this opinion is not necessarily accepted by other geologists, the existence of these 2 glacial epochs with intervening glacial period is considered conclusively established. Succession of cold and warm climates must characterize these glacial and interglacial periods, which were also accompanied by extensive movements of depression and elevation of the land, the depression taking place after the land was weighed down by the enormous mass of ice. Thus, a period of glaciation was marked by elevation, extreme cold, and the evasion of ice caps over regions of the present temperate zone, while the interglacial period was accompanied by the depression of land and a milder congenial climate, which made even the Arctic regions inhabitable. The remains of Paleolithic man have been found often embedded between 2 boulder clays of different glacial periods, fact which conclusively establishes the existence of man in the interglacial period of the Quaternary era. Professor Geikie, speaking of changes of climate in the glacial and interglacial period, remarks that during the interglacial period the climate was characterized by clement winters and cool summers, so that tropical plants and animals, like elephants and rhinoceros, hippopotami, ranged over the whole of the Arctic region, in spite of numerous fierce carnivora. The Paleolithic man had no unpleasant habitation there. It will thus be seen that point of climate in the Pleistocene period, or the early Quaternary era, was intermediate between the early geological ages when uniform genial climate prevailed over the globe, and the modern period when it is differentiated into zones. It was, so to speak, a transitional period marked by violent changes in the climate that was mild and genial in the interglacial and severe and inclement during the glacial period. It was at the beginning of the postglacial or recent period that the modern climatic conditions were established. Professor Geikie, however, is of the opinion that the beginning of the postglacial period is marked, at least in northwestern Europe, by 2 alterations of genial and rainy cold climate before the present climatic conditions became established. But though the fact of the Ice Age and the existence of milder climate within the Arctic regions of the interglacial time was indubitably proved, yet scientific men have not been able as yet to trace satisfactorily the causes of the great catastrophe. Such immense mass of ice as covered the whole of northern Europe and America during this period could not, like anything else, come from nothing. There must have been heat enough in certain parts of the globe to create, by evaporation, sufficient vapor and aerial currents as required to transfer it to the colder regions of the globe, there to be precipitated out in the form of ice. Any theory regarding the cause of the Ice Age which fails to take the fact into account is not only inadequate but worthless. The succession of glacial periods, or at any rate, the occurrence of two glacial periods, must again be accounted for in a theory which may be proposed to explain these changes. If we test the different theories advanced in this way, many of them will be found to be at once untenable. It was, for instance, once urged that the Gulf Stream, which at present imparts warmth to the countries of northwest Europe, might have been turned away from its course in the Pleistocene period by the submergence of the Isthmus of Panama, thus converting the countries of the northwestern coast of Europe into lands covered by ice. This, however, has no geological evidence to show the Isthmus of Panama was submerged in the Pleistocene period, and we must therefore give up this hypothesis. Another theory started to account for the catastrophe was that the Earth must have passed through cold and hot regions of space, thus giving rise to glacial and interglacial periods respectively, but this too was unsupported by any modern evidence. The third suggestion advanced was the supply of solar heat on the Earth must have varied in such a way as to give rise to warm and cold climates. This also has been shown to be mere conjecture. A change in the position of the Earth's axis might indeed cause such sudden changes to the climate, but a change in the axis means a change in the equator, and as the Earth, owing to its diurnal rotation, causes the equatorial regions to bulge out, a change in the axis would give rise to a secondary equatorial protuberance, which however is not observable, and the theory cannot therefore be accepted. The gradual cooling of the Earth would make the polar regions habitable before the other parts of the globe, but a succession of glacial epochs cannot be accounted for with this theory. Thus, out of the various theories advanced to account for the vicissitudes of climate in the Pleistocene period, only two have remained in the field. The first, that of Lyell, which explains the changes by assuming different distribution of land and water combined with the sudden elevation and submergence of large land areas, and the second, that of Croll, which traces the glaciation to the precession of the equinoxes, combined with the high value of the eccentricity of the Earth's orbit. This last theory is worked out to show geographical changes are by themselves sufficient to produce heat and cold required to bring on glacial and interglacial periods. We've seen that in earlier geological ages, a pleasant and equable climate prevailed over the whole surface of the globe, owing mainly to different distribution of land and water, and the theory advanced by Lyell to account for the glacial epoch is practically the same. Great elevation and depression of extensive areas can be effected only in thousands of years, and those who support this theory are of the opinion that the duration of the glacial epoch must be taken to be about 200,000 years in order to account for all the geographical and geological changes, which according to them were principal causes of the glacial periods. But there are others, geologists, the same school, who hold that the glacial period may not have lasted longer than 20 to 25,000 years. The difference between the two estimates is enormous. With the present state of geological evidence, science must decide in favor of one of these views. All that we can safely say is the duration of the Pleistocene period, which included at least two glacial and one interglacial epoch, must have been very much longer than the period of time which has elapsed since the commencement of the post-glacial period. According to Sir Robert Ball, the whole difficulty of finding out the cause of the glacial period vanishes when the solution of the changes sought for in astronomy rather than geography. Changes which seem to be so gigantic on the globe, it is said, but are daily wrought by cosmological forces which are familiar to astronomy. One of the chief merits of the Croll theory, supposed to consist of the fact that it satisfactorily accounts for the succession of glacial and interglacial epochs during the Pleistocene period. Dr. Croll, in his Climate and Time and Climate and Cosmology, tried to explain and establish his theory by elaborate calculations showing that changes in the value of variable elements in the motion of the Earth around the Sun can adequately account for the climatic changes of the Pleistocene period. We shall first briefly state Dr. Croll's theory and then give the opinion of experts as regards to its probability. When letting P to Q prime AQ represent the orbit of the Earth around the Sun, the orbit is an ellipse, and the Sun, instead of being in the center, C, is one of the foci, or large S or little s. So we'll let the Sun be at large S. The distance between the Sun from the Earth when the latter is at large P, or perihelion, would be the shortest, while when the Earth is at A, it would be the longest. The points A and P are respectively called perihelion and aphelion. The seasons are caused, as stated above, by the axis of the Earth being inclined in the plane of its orbit. Thus, when the Earth is at P, and the axis turned away from the Sun, it will produce winter in the northern hemisphere, while when the Earth is at A, the axis, retaining its direction, will now be turned towards the Sun, and there will be summer in the northern hemisphere. If the axis of the Earth had no motion of its own, the seasons would always occur at the same points in the orbit of the Earth, as for example, the winter in the northern hemisphere at P and summer at A. But this axis describes a small circle around the pole of the ecliptic, giving a cycle of 25,868 years, which gives rise to what is called the procession of the equinoxes, and consequently the indication of the Earth's axis in the plane of its orbit is not always the same at any given point in its orbit during the period. This causes the seasons to occur at different points within the Earth's orbits and during this great cycle. Thus, if winter in the northern hemisphere occurred when the Earth was at P at one point, sometime after it could occur at succeeding points in the orbit until the end of the cycle, when it would again occur at P. The same would be the cause in regard to summer at point A and equinox at Q and Q prime. In the diagram, the dotted line, little q, Q prime, and little p, A, representing new positions in which the large Q prime, and the large P, large A, would assume that they revolve in the way stated above. It also must be noted that, though winter in the northern hemisphere may occur when its Earth is at little p instead of big P, owing to the aforesaid motion of its axis, yet the orbit of its Earth and the points of perihelion and aphelion are relatively fixed and unchangeable. Therefore, if winter in the northern hemisphere occurs at one of the small p, the Earth's distance from the Sun at the point will be greater than when the Earth was at the large P. Similarly, in the course of the cycle as mentioned, winter in the northern hemisphere would occur once at large A, and the distance of the Earth from the Sun will then be its longest. Now, there is a vast difference between a winter occurring when the Earth is at perihelion and a winter occurring when the Earth is at aphelion. In the first case, the point P of perihelion being nearest the Sun, the severity of the winter will be greatly modified by the nearness of the Sun. But when the Sun is at the farthest removed from the Earth, the winter, when the Earth is at aphelion, will naturally be very severe, and during the cycle the winter must at least once occur at aphelion. The length of the cycle of 25,868 years, and ordinarily speaking, half this period must elapse before the occurrence of winter is transferred from the Earth's position at perihelion to its position at aphelion. But it's found that points perihelion and aphelion have small motion of their own, and the direction opposite to which that is the line of the equinox of Q and Q prime, or the winter point P, moving along its orbit. The above cycle of 25,868 years is therefore reduced to 20,984, or in a round number, about 21,000 years. Thus, if winter in one hemisphere occurs when the Earth is at perihelion, the point nearest to the Sun in orbit, it will occur in the same hemisphere at aphelion after a lapse of about 10,500 years. It may be mentioned here that in about 1250 AD, winter in the northern hemisphere occurred when the Earth was in its orbit was at perihelion, and that was about 11,750 AD. The Earth will again be at aphelion, that is, at its longest distance from the Sun in winter time, giving rise to severe winter. Calculating backwards, it may be seen that the last severe winter at aphelion must have occurred in the year 9250 BCE. It need not be mentioned that the winter in one hemisphere corresponds with summer in the other, and what is said about winter in the northern hemisphere applies to seasonal changes in the southern hemisphere. There's another consideration which we may take into account in estimating the severity of winter, the mildness of summer in any hemisphere. If the summer is to be defined as the period of time required for the Earth to travel from one equinox point to another equinoctial point, Q prime to Q, this interval cannot always be constant, for we have seen that winter and summer points of perihelion and aphelion, and that with them the equinoctial points of Q and Q' are not stationary but must revolve along the orbit once in approximately 21,000 years. Had the orbit been a circle, those lines of Q and PA would always been divided into equal parts. But the orbit being an ellipse, these two sections are unequal. For instance, suppose winter occurs when the Earth is at perihelion, and the duration of the summer will be represented as Q' to aphelion to Q. But then, when the winter occurs at aphelion, the summertime would be represented by Q, perihelion, Q', and the segment of the ellipse is necessarily smaller than the previous. This inequality is due to the ellipticity of the orbit, and the more elongated or elliptical of the orbit is, the greater will be the difference between the durations of summer and winter in a hemisphere. Now, the ellipticity of the orbit is measured by the difference between the mean and the greatest distance of the Earth from the Sun, which is called in astronomy the eccentricity of the Earth's orbit. This eccentricity of the orbit is not constant quantity, but varies, though slowly, in the course of time, making the orbit more and more elliptical until it reaches a maximum value, when it again begins to reduce until the original value is reached. The duration of summer and winter in a hemisphere, therefore, varies as the value of the eccentricity of the Earth's orbit at the time, which has been stated above as the difference between the duration of summer and winter, also depends on the position of the equinoctial line, or the points of the Earth's orbit at which the summer and winter in the hemispheres occur. As the joint result of these two variations, the difference between the durations of summer and winter would be the longest when the eccentricity of the Earth is at its maximum, and according as the winter and summer occur at the points of perihelion or aphelion. It has been found this difference is equal to about 33 days at the highest, and at the present day it is about 7.5 days. Thus, if winter in the northern hemisphere occurs when the Earth is at perihelion in its orbit, the eccentricity is at its maximum, winter would be shorter by 33 days than summer at the time. But this position is altered after 10,500 years, when the winter occurring in aphelion will, in its turn, be longer than the corresponding summer by the same length of time, 33 days. Now, since the Earth describes equal area in equal time in its orbit, Herschel supposed that in spite of the difference between the duration of summer and winter noticed above, the whole Earth received equal amount of heat while passing from one equinox to the other, the inequality of the intensities of solar radiation in the two intervals being precisely compensated by the opposite inequality in the duration of the intervals themselves. According to this statement, Dr. Croll understated his ease to a certain extent. But Sir Robert Ball, formerly the Astronomer Royal of Ireland, in his work *In the Cause of the Ice Age*, did demonstrate by mathematical calculation that the above supposition is erroneous, and that the total amount of heat received by the Sun in each hemisphere in summer and winter varies in the obliquity of the Earth, or the inclination of its axis to the ecliptic, but is practically independent of the eccentricity of the Earth orbit. Taking the total sun heat received in a year by each hemisphere to be 365 units, or on average 1 unit a day, and the obliquity of 23 degrees 27 minutes, Sir Robert Ball calculated that each hemisphere would receive 229 of these heat units during the summer, but only 136 during the winter, whatever the eccentricity of the Earth may be. Though these figures are not affected by the eccentricity of the orbit, we have seen that the duration of the summer and winter does vary with the eccentricity. Supposing, therefore, we have the longest winter in the northern hemisphere, we'll have to distribute 229 heat units over 166 days of a short summer, and 136 heat units over 199 days of a long winter of the same period. In other words, the difference between the daily average heat in summer and winter will, in such a case, be the greatest, producing shorter but warmer summers and longer and colder winters, and the ice and snow accumulated in a long winter will not be melted or removed by the heat of the sun in the short summer, giving rise thereby to what is known as the glacial period in the northern hemisphere. From what has been stated above, it may be seen in the southern hemisphere during this period will have long and cool summers, short and warm winters, condition precisely reversed to that of the northern hemisphere. In short, the glacial and interglacial periods in the two hemispheres will alternate with each other every 10,500 years, and if the eccentricity of the Earth be sufficiently great to make perceptible large difference between winter and summer in each hemisphere. If Dr. Croll had only gone so far, his position might have been unassailable, for the cause enumerated above is sufficiently potent to produce climatic changes attributed to it. At any rate, this was not the sole cause of the succession of glacial and interglacial periods. There could be no doubt that there must have been an important contributory cause bringing about these changes, but in taking the value of the eccentricity of the Earth's orbit from the tables of Leverrier, Dr. Croll calculated that during the last 3 million years there were 3 periods of maximum eccentricity. The first, of 170,000, the second, 260,000, the third, 160,000 years, and that 80,000 years had elapsed since the close of the third or last period. According to Dr. Croll, the glacial epoch in the Pleistocene period therefore must have begun 240,000 years ago and ended, followed by the post-glacial period about 80,000 years ago. During this period of 160,000 years, there must have been several alterations of mild and severe climates, according as the winter in the hemisphere occurred when the Earth was at perihelion or aphelion in its orbit, which happened every 10,500 years throughout the period. But this cold epoch can be at its maximum only during the early part of each period, according to Dr. Croll's theory. And the last epoch of maximum glaciation must be placed at 200,000 years ago, or about 40,000 years after the commencement of the last period of maximum eccentricity. The reliability of these elaborate calculations has, however, been questioned by astronomers and geologists alike. Sir Robert Ball, who supports Croll in every other respect, has himself refrained from making any astronomical calculations regarding the maximum value of eccentricity of the Earth's orbit, or the time when the last glacial epoch should have occurred, or when the next would take place. "I cannot say," he observes, "when the last glacial epoch took place, nor when the next may be expected. No one who is competent to deal with mathematical formulae would venture on such predictions in the present state of our knowledge." Professor Newcomb of New York, another astronomer of repute, in his review of Dr. Croll's Climate and Time, also pointed out that in the present state of astronomical knowledge it's impossible to place any reliance on the values of eccentricity computed for epochs distant by millions of years, as the value of this eccentricity depends upon elements, many of which are uncertain, and is especially the case when one has to deal with long geological eras. The only reply made by Dr. Croll to the criticism is that his figures were correctly worked up from the values of the eccentricity according to the latest correction of Mr. Stockwell. This, however, is hardly a satisfactory answer, inasmuch as Professor Newcomb's objection refers not to the correctness of the mathematical work, but to the impossibility of correctly ascertaining the very data from which the values of the eccentricity were obtained. It was once supposed that the duration of each of Dr. Croll's different periods admirably fitted with the geological evidence and fully corroborated the estimates of time supposed to be required for extensive geographical changes which accompanied the glacial and interglacial periods. The geologists now began to take more sober view of this extravagant figures and calculations. According to Croll's calculation, there were 3 periods of maximum eccentricity in the last 3 million years, which there should be 3 periods of glaciation corresponding to these, each including several glacial and interglacial epochs. There is no geological evidence of the existence of such glacial epochs in early geological eras, except perhaps of the Permian and Carboniferous periods of Paleozoic or Primary Age. An attempt is made to meet this objection by replying that though the eccentricity was greatest at one period in the early geological eras, yet its geographical distribution of land and water was then essentially different from what it was in the Quaternary era. The high value of eccentricity did not then produce the climatic changes that it did in the Pleistocene period. This reply practically concedes the high eccentricity of the Earth's orbit combined with the occurrence of winter when the Earth is at aphelion is not itself sufficient to bring about a glacial epoch, and it may therefore be well urged that a glacial epoch may occur when their eccentricity is not at its maximum. Another point at which Dr. Croll's theory conflicts with geological evidence is the date of the close of the last glacial epoch. As ascertained by American geologists, from estimates based on the erosions of valleys since the close of the last glacial period. As pointed out in the last chapter, these estimates do not carry the beginning of the post-glacial period much further than about 10,000 years ago at best, while Dr. Croll's calculations would carry it back 80 or 100,000 years. This is a serious difference, and even Professor Geikie, who does not entirely accept the American view, is obliged to admit that though Dr. Croll's theory is the only theory which accounts for the succession of glacial epochs and therefore the only correct theory, yet the formula employed by him to calculate the values of the eccentricity of the Earth's orbit could be incorrect, and that we may thus account for the wide discrepancy between his inference and conclusions based on hard geological facts, which cannot be lightly set aside. A judgment recently pronounced by Mr. Hudleston is even more severe. In his opening address, the president of the geological section of the meeting of the British Association in 1898 was reported to have remarked, "There's probably nothing more extraordinary in the history of modern investigation than the extent to which geologists of an earlier date permitted themselves to be led away from the fascinating theories of Dr. Croll. An astronomical explanation of the will-o'-the-wisp, the greatest cause of the Ice Age, is presently greatly discredited, and we will begin to estimate at their true value those elaborate calculations which were made to account for these events, which in all probability never occurred. Extravagance begets extravagance, and other unreasonable speculations of men like Belt and Croll has caused some of our recent students to suffer from nightmare." This criticism appeared to be rather severe. Though Dr. Croll's elaborate calculations may be extravagant, yet we must give him credit for not merely suggesting, but working out the effect of the cosmological cause, which under certain circumstances is powerful enough to produce extensive changes in the climate of our globe. But in spite of these remarks, it cannot be doubted that the duration of the glacial period, comprising at least 2 glacial and 1 interglacial epoch, must have been very much longer than that of the post-glacial period. For, independently from the eccentricity of the Earth's orbits, the occurrence of winter at aphelion is by itself sure to contribute to the production of the Ice Age. If other causes and circumstances, either those suggested by Lyell or others, are favorable, then the 21,000 years must elapse between 2 successive occurrences of winter at aphelion. For 2 glacial epochs and an intervening interglacial period, we must therefore allow a period of longer than 21,000 years, even if the question of eccentricity of the Earth's orbit is to be kept aside, while, if with Professor Geikie we suppose that there were 5 glacial, 4 in the Pleistocene and 1 at the close of the Pliocene period, and 4 interglacial epochs, the duration of which must extend to something like 80,000 years, it is unnecessary to go further into these scientific and geological discussions. As already stated before, our object is to trace, from positive evidence contained in the Vedic literature, the home of the Vedic and therefore of other ancient races long before they settled in Europe or in the banks of the Oxus, the Jakartas, or the Indus. And so far as this purpose is concerned, the results of scientific researches discussed in this and previous chapters may now be summed up as follows. 1. In the very beginning of the Neolithic Age, Europe was found to be inhabited by different races, from whom the present race of Europe is descended. 2. Though the existence of an ancient race in Europe in early Neolithic times was established, and is therefore the theory of migrations from an Asiatic home in post-glacial time does seem untenable, does not prove that the ancient race was in Europe, and that the question of its original home cannot therefore be regarded as finally settled. 3. There are good reasons for supposing the Metal Age was introduced into Europe by a foreign people. 4. Different ages of stone, bronze, and iron were not synchronous in different countries, and the high state of civilization in Europe is not, therefore, inconsistent with the Neolithic stage of European civilization at the same time. 5. According to geological evidence, which cannot be lightly set aside, the last glacial period must have closed, post-glacial commenced around 10,000 years ago, or about 8,000 BC at the best, and the freshness of the Siberian fossil deposits favors this view. 6. Man is not merely post-glacial, as he was believed to have been some years ago, and there is conclusive geological evidence to prove his widespread existence in the Quaternary, if not also in Tertiary era. 7. there were at least 2 glacial and 1 interglacial period, and that the geographical distribution of land and water in the Earth during the interglacial period was quite different from what it is at present. 8. There was great vicissitudes of climate in the Pleistocene period, it being cold and inclement during the glacial and mild and temperate in the interglacial periods, even as far as the polar regions. 9. There's enough evidence to show that the Arctic regions, both in Asia and Europe, were characterized in the interglacial period by cool summers and warm winters, a sort of what Herschel calls perpetual spring, and that places like Spitsbergen, where the sun now goes below the horizon from November to March, where once the seat of luxuriant vegetation that grows at present only in temperate or tropical climate. 10. It was the clumping of the glacial age that destroyed this genial climate, rendering the regions unsuitable for habitation of tropical plants and animals. 11. There are various estimates regarding the duration of the glacial period. The present state of our knowledge, it is safer to rely on geology than on astronomy in this respect, though as regards the cause of the ice age, the astronomical explanation appears to be more probable. 12. According to Professor Geikie, there's evidence to hold that there were in all 5 glacial and 4 interglacial epochs, and that the beginning of the post-glacial period was marked by 2 successions of cold and genial climate, at least northwestern Europe. 13. Several eminent scientific men have already advanced the theory that the cradle of the human race should be sought for in the Arctic regions, and that plant and animal life also originated in that same place. It will thus be seen that if the Vedic evidence points to an Arctic home, where the ancestors of the Vedic rishis lived in ancient times, there is, at any rate, nothing in the latest discoveries which would warrant us in considering this result a priori improbable. On contrary, there is much in these researches that suggests that such a hypothesis, and as a matter of fact, several scientific men have now been led to think that we must look for the cradle of the human race in Arctic regions.